Good morning, students. This is the OAA Pillow problem that we talked about in class several days ago. And if you got less than 3 points on this problem, you need to watch this video so that you can understand how to approach a problem like this in the future. So the first thing that we do whenever we encounter a problem like this is to read the problem very carefully. Now, I can tell just by glancing that this is a 4-point problem, so I should be expecting a total of 4 tasks. So as I read, I'm going to highlight important data. Now, normally I would just read the entire problem first, but we've already done that several times as a class. So I'm going to start by reading the problem as I highlight. Carson wanted to make a cylindrical pillow for his mother's birthday. The pillow was to be 15 inches long with a diameter of 6 inches and would be filled with stuffing. In your answer document, determine how many cubic inches of stuffing Carson will need to make the pillow. Show your work. Before he started making the pillow, Carson decided he wanted to make it bigger. Compare the amount of stuffing needed when he doubles the length to the amount of stuffing needed when he doubles the diameter. Show work or provide an explanation to support your comparison. Respond completely in your answer document. It's worth 4 points. All right, so a lot of tasks here. The first task that I have is to figure out how much stuffing I would need if I'm making this pillow, which is 15 inches long and 6 inches in diameter. So that's my first task. So if I'm going to do that first, great. So I just have that part highlighted. I'm going to find how much stuffing I need. So if I'm going to find how much stuffing I need, that is the volume. So the formula for volume of a cylinder is equal to pi times r squared times height. So the volume formula for a cylinder is pi r squared times height. So this little caret means raised to the second power. These stars mean times. So that's my formula for volume, something I have to have memorized. Here is what my pillow would look like. Now notice that they gave us information for the diameter, which is 6 units. So the diameter is the distance across the circle through the center. And I also have distance for the length, inches long. So this would be how long it is, a total of 15 inches. Notice that the pillow is really a cylinder on its side. So our formula says height. If we imagined tipping up this cylinder so it was vertical, I imagine tipping this up so it was vertical, the length would become the height. So I'm going to leave it over here as I had drawn it, but so instead of the length, we're talking about the height. So I'm going to go ahead and substitute in the information that I know for this problem. So volume is equal to pi, and I'm going to use my calculator to use the number 3.14159. My radius is not 6. My radius is 3 because radius is half of the diameter, so 3 squared times 15. So I follow order of operations. First step, I do 3 squared, which is 9 times 15. And then I am going to pull up a calculator. On this calculator, I do not have a pi button. I'm going to multiply 9 times 15, and if I do that, I get 135. So volume is equal to pi times 135. And then I'm going to multiply this by 3.14159, and I get 424 point something. I didn't get a look at that, 0.11. And my label is going to be inches cubed. Inches cubed, because this is volume that I'm talking about. So that's the first part of this problem. That is how many cubic inches of stuffing Carson will need to make the pillow. So I'm going to write that in a sentence so the grader knows what I've done. So Carson will need 424.11 cubic inches of stuffing to make the pillow for his mother. So that is part 1. Part 2 will be in the next part of this video.